Ah.
I'll send it now. Work hard.
Oh my God.
But I need enough. Like
Good morning.
Am I serious? I thought it was Uh-huh. When it's time for me, it's supposed to have. And she should just write. And nothing God cannot. Jesus.
Mute your mic now.
Hello, good morning. Morning.
Food. On the dining. What cover it now? You're not getting food.
Right. Good job. All right. Hello. Good morning. Morning. Hello. Good morning.
Good morning,
Good
sir.
morning. Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir. Good morning, sir.
Morning, sir.
All right.
Good morning, sir.
Morning. Okay. All right. Good morning. Yeah. Today, you pardon me for the. All right. So today we'll talk about I hope you can see my screen. All right. So today we are talking about mitochondria regarded as power out of the cell. That is the ending count organelle. the double membrane bound organelle that resides within the cytoplasm. And this organelle also has a circular nucleus. It has a circular nucleus, which resembles that of mitochondria. So, pardon me. Okay, good. Mitochondria is 0.5 to 1 micrometer in diameter. It's sausage shaped, and the number depends on the functional state of the cell. So if the cell is very active, you have more mitochondria. If it is less active, you have less mitochondria. We can divide the mitochondria into the outer membrane, intermembrane space, inner membrane, cristae, and the matrix. Right. So here we have an image of the mitochondria. So please be reminded, plural is mitochondria, singular is mitochondrion. All right. So you have the sausage-shaped mitochondria here, mitochondrion, and you have the outer membrane, which is that one tipped in red, and you have this inner membrane in yellow, and it's thrown into folds called cristae. Okay, because this inner membrane is thrown into folds, we call those folds cristae. All right, and on the membrane, on the inner membrane, you have the electron transport chain on the inner membrane. Also, remember the circular DNA that is within the mitochondria, and also it has ribosomes, maybe some granules. The outer membrane is a phospholipid bilayer also. Okay, and the inner membrane is also a phospholipid bilayer. But the outer membrane has proteins called porins, which allow things inside, and it regulates what comes into this mitochondrion and what goes out of the mitochondrion. Between the outer membrane and the inner membrane, you have a space. All right. So you have the intermembrane space between the outer membrane and the inner membrane. And you can see the artist's impression. Those are the inner membrane that is thrown into cristae. All right. In your biology, primary school biology, when you were still in your primary school, you were taught glycolysis and you were taught Krebs cycle. Am I correct? Is that correct?
Yes, sir.
Oh,
Yes,
good.
sir.
Okay, so
Yes, sir.
glycolysis takes place in the cytoplasm. All right. And then once it gets to that pyruvate stage, pyruvate goes to acetyl-CoA, and acetyl-CoA goes into the mitochondria. So the Krebs cycle takes place in the mitochondrial matrix. Okay. While glycolysis takes place in the cytoplasm. All right. So during Krebs cycle, or what's called the citric acid cycle, intermediates are formed and reducing equivalents are generated. By reducing equivalents, I mean NADH2 and FADH2. They are generated. And these are transferred to the electron transport chain, which is located on the cristae. All right? This is the electron transport chain. You have the complex 1, complex 2, complex 3, and complex 4. So complex 1 is where NADH goes in. And once it goes in, there is protons are released into the intermembrane space. Please mute yourself on entry. Mute yourself on entry, please. Okay. Pardon me. So once those reducing equivalents locate the electron transport chain, like NADH goes in at the first complex, and protons are moved into the space, intermembrane space. Okay. FADH comes in at the second complex. Okay. Also, protons are moved into the intermembrane space. All right. So basically, look at it this way. If NADH is the one bringing the hydrogen, your reduced equivalent, it is going to generate 3 protons, which will be moved into the intermembrane space. But if it is FADH, it is going to generate 2 protons, which is going to be moved into the intermembrane space. All right. And this is very critical because that's why when you have to account for the number of ATP produced from metabolizing 1 mole of glucose, it is important you pay attention to this. In the Krebs cycle, 30 ATP are generated. 30 ATPs are generated in the Krebs cycle, while in the glycolysis, 6 is generated. So you need to be able to account for the 30 ATPs, and this is how you do that. When you look at your citric acid cycle, you look for where NADH NAD is reduced to NADH2. You look for where FAD is reduced to FADH2. And also there's another step where
Excuse me,
GTP
sir. Your screen is not shared, sir. Your screen is no longer shared.
is no longer shared. Oh,
Yes, sir.
if people have bumped me out, is that oh God. What do we do? Okay. Okay, trying to connect back. Right, network. Oh. Right, what I'll do is simple. I'm trying to connect. So
Okay, sir.
switch my data. Then okay, I'm switching my source of data. Let's see what's gonna happen. All right, okay. Just a minute. Right. So then just one. Okay, I'll just keep going on the start. All right, so I need you to remember your Krebs cycle. Okay, during the Krebs cycle, pyruvate coming from glycolysis is fed into the Krebs cycle. Okay, so reducing equivalents are generated. NADH, NAD plus is reduced because takes on hydrogen. Okay, so you look in the Krebs cycle and see how many molecules of NADH2 is formed. You look at the Krebs cycle and see how many molecules of FADH2 is formed. All right. And then importantly, there is one molecule of GTP that is formed. That GTP that is formed actually interacts with ADP and produces ATP. Okay. You should also note when in your calculation from glycolysis, there's a step in glycolysis where two 3 carbon molecules are produced. And those 2 3 carbon molecules will account for one cycle. That is each carbon, that's glyceride 3-phosphate, will account for one cycle of one Krebs cycle. So you need to remember that when you are calculating it. So like I was saying, sorry that you can't see it now. So what happens is that the Christe, which houses the electron transport chain, has complex 1, complex 2, 3, and 4. I said NADH2 will go into the electron transport chain from complex 1. And once it moves through the electron transport chain, please mute yourself once you are in.
Excuse me, sir.
Yes.
Yes, sir. You said the number of ATP produced in the Krebs cycle is how many? And also in the one in the glycolysis is how many? You mentioned the number earlier, sir. I didn't hear clearly.
Well, you need to look up the Krebs cycle. It's 30.
Okay,
in
sir.
Krebs cycle.
Okay, sir.
What I'm saying is this. Entering the Krebs cycle, the acetyl-CoA entering the Krebs cycle is derived from pyruvate, phosphoenol pyruvate rather. So, and that one is derived from glyceride 3-phosphate. Okay. Now, glyceride 3-phosphate can be interconverted. Okay, so I can't join because maximum. And is anybody willing to cut out, or do I have to create another link? Nobody.
I can come out too.
So
People are coming out already, sir.
Yeah. You're coming out already. So,
Yes, sir. You can join now.
Yes, sir. Yes, sir.
right. Yeah. Thank you. Thank you very much. Bye-bye.
Will you be able to share your screen now, sir? Because it's not yet shared.
Guy, you calm down, Joe.
I've not even logged on. I've not accepted.
We no say this. He has not even joined, sir.
Because capacity is there. Whoever it is that left, somebody else give me. Person is faster than I. Maybe I have to create another link. Somebody else left. Please kindly allow me in. Please. Somebody else has joined. Then I have to make another link. Or else we just keep doing it.
It's all right. It's all right, sir.
All right. So give me 5 minutes. I'll make 3 minutes or so. Let me make another link. Thank you.
Excuse me, sir. Share the link on the chat, please.